Hi. Yeah, so actually, I don't have much trouble saying no to something that I don't think I'll enjoy. I'll wiggle my way out of those. But saying no to something that seems awesome, I am exceptionally bad at. And that's why I've had a to-do list beside my laptop with personal projects since December of 2014, when I first discovered my passion for the visualization of data. I do cross things off every now and then, but new items appear just as fast. But in hindsight, I don't mind this permanent lack of having enough free time left to actually get bored. I think that my personal projects have given me opportunities that I didn't even know I was looking for. And they also played a really big role in me being able to pursue a freelance career almost 3 years later. And my favorite personal project is the one that I want to share with you today. It was indeed a year-long, maybe a year-plus long, collaboration that I did with Shirley, who is like me, a data visualization freelancer, although she is based in San Francisco and I'm based in Apkoude, which is right outside of here in Amsterdam. And to set the scene, a bit of background, Shirley and me first met virtually in a DataVis Slack channel after meeting in real life a few months later at OpenVisConf, where we both had the honor to speak and we really hit it off during those 3 days. A few weeks later, I was publishing tutorials about the different aspects of my talk, and Shirley really jumped on them, asking me all kinds of questions. And somewhere during those chats, we started lamenting the fact that we hadn't created as many more advanced data visualizations than the previous year. We'd been focused more on smaller examples, tutorials, and maybe some talks. And yeah, we were sad about that. And suddenly, Shirley asks me, well, do you want to collaborate and create stuff? And I think it took me mere seconds to reply with an all-capital yes, and that's how Data Sketches was born. So in the following week, we figured out that we both liked the idea where we would create a visualization each month around a specific topic, and then for a year, to see how two people would create two visualizations, starting from that same seed, but diverging into different directions based on our own interests and history. So besides sharing that end result, we also wanted to write about the creation process. And we split this up into the 3 pillars that we find most important: data, sketching, and coding. And initially we thought we could pull data sketches off in about 5 to 6 hours a week. But yeah, real life really doesn't care about plans, especially coding plans, I find. So since starting, we've clocked many hours into creating our visualizations each month. And during this talk, I actually like to take you through some of those lessons that I learned, challenges faced, and insights that I gathered along the way. So to start off with the most fundamental aspect of data visualization, the data itself. So a question we often get is, how do you find your data? But it's typically not the data that leads us. It's the topic of each month that first provides a spark of an idea, an insight that we might want to reveal on how we could visualize that. And only after we have that more concrete angle do we investigate to see if we can find some more appropriate data. And for example, our topic for November was books, pretty broad. But I really wanted to focus on fantasy books, and even more specifically, the themes in titles of fantasy books. And after I have that more concrete angle, I do nothing more special than just combine that word with the word data or dataset, and then Googling and having the patience to investigate each link on the first 2 or 3 pages of results. And this has led me to Google spreadsheets containing thousands of rows of Olympic medal winners, or GitHub repos with wonderfully unique datasets, such as one about the words spoken in The Lord of the Rings, or a family tree of 3,000 people connected to royalty going back more than a millennia. I've also come to realize that website design says nothing about the quality of the data it shares. So there are also websites that have structured information, but not in some ready-to-download format. Instead, I have to scrape the logical layout of the website and put the information that it contains in a file with the help of some code. IMDb, for example, has a pretty advanced search, and it returns a list of movies. And each of these movies is contained within the same set of divs and other stylings. So I can therefore download the HTML, and with the help of some code, search for all of the stylings that follow a certain pattern. All of the movie titles could be contained within a H-something class movie title. Or, as another example, on Amazon, I was able to find the 100 best-selling fantasy authors in a list that I could scrape and then have a list of 100 authors. So there are also APIs from which you can request information, although I have to admit I don't often use these because they can be quite a hassle to set up. Nevertheless, sometimes the wealth of information is just too good to ignore. So using those author names that I scraped from Amazon, I then used the Goodreads API to request information about the top 10 best rated books of each author, gathering info on the number of ratings, the average rating, and of course the titles of their books. Another good strategy can be to just ask others for advice. And for April, our topic was community. And I knew I wanted to do something about that would fit the World Wildlife Fund in a way. But I couldn't get my angle any more concrete than that, so I asked on Twitter for advice. And I got a dozen or so interesting links back. So then I started browsing, which led me to new links and so on, until I finally came across this webpage, where I saw an image of the greenness as measured from space in a week in June. And when I saw this, I knew I'd found my hook. I wanted to visualize the same information, but animate it smoothly throughout the year and try my own spin on the visual styling. So eventually that led into this result, which proved technically quite complex because it was a lot of data, but the visualization itself is very minimal. With just a title and a simple legend, I think is enough for most to understand what they're looking at. And finally, you can create a dataset completely manually, no code required. For our Nostalgia Month, I dove into Dragon Ball Z. I'll get back to the visual later, but on the Dragon Ball wiki pages, I found these lists of all the fights that happened during this anime. And I just copy and pasted all of these lists into Excel and then split them up into the separate characters and other metadata. And it took me about 2 hours to get the data ready for these 200 fights, which I still think is a lot less time than if I tried to write a scraper to handle all of the nuances that were in the text in these lists. Or when I really did spend 2 hours trying to find a proper data set on the characteristics of butterflies, but had to resign myself that the best option seemed to be contained within a website called Gardens with Wings. There is nothing better. Again, I felt that trying to write a scraper to go through this semi-structured website would take more time than a manual approach, so I just clicked through all of the options and put the information that it contained into a final data set of 87 different butterfly species. So what I hope to have shown you with all of these different examples is that there's not just one specific way to find data. It's not just hardcore data analysts that have these magical skills. They can be found in so many different ways, from Googling and finding the straightforward CSV or Excel file to scraping a website or even making it yourself. But it is good to know that typically, I would say in 99 out of 100 cases, you would still need to do some data preparation or adjustment to get it into the shape that you need for your visualization. So to get a little bit more about what kind of preparations those could be, for August, the obvious theme was the Olympics, especially since we are both big fans. And I ended up visualizing all 5,000 gold medal winners since the very first games in 1896. And we have these 5 circles, and each circle is a group of similar sports. So we have water sports, ball sports, and here gymnastics. And within that, each feather or slice is a specific sport. So we have athletics over here. And then on the inside, we have the first edition all the way to 2016 on the outside. The reddish background is female events, and the blue background is male events. And then finally, the color of each medal is decided by the continent in which the country lies that won. So Europe is blue, Americas is red, Africa is black, and so on. And we can see some fun things from this. For example, tug of war used to be an official Olympic sport at the start of the Olympics. And I'm so sad we don't have like a national tug of war team anymore. That would kind of be fun. But yeah, you can really kind of see or look into the sports that you are most interested in. And I actually initially found the data for this piece from 2 articles published by The Guardian for the Games in 2012 in London. But after getting a rough shape of the visual on my screen, I noticed that some very obvious medals were missing, like hockey. And so suddenly my confidence in this data set dropped drastically, even coming from such a respectable source. So I had to get a sense of the overall accuracy before moving on. However, I didn't want to have to manually investigate all 5,000 medals, so I found a proxy instead. On Wikipedia, I could find the number of events that had occurred during each edition, which I could then compare to the number of gold medals I had in my dataset. And if there was a discrepancy, I investigated further to figure out where and why. And that's how I found out that for some of the editions, the horses were also in the dataset, which makes for an interesting read to suddenly see Princess and Sissy and Lady Mirka as women winning gold in the Olympics. And I found a few more interesting things and facets, made some changes to get the dataset back to the point where I trusted it again. So my lesson here is, and I've been learning it ever since I was a data scientist, but I guess I need to learn again, you really need to get a feeling of accuracy and completeness of your data. Missing data can actually be harder to find than wrong data. And you don't have to check every value, but think about taking sums and counts and averages, and either comparing that to plain common sense, can a percentage be higher than 100, or even better, a different data source. And looking into data preparation and how that can also be connected to creating more exotic and unique visuals. So the standard bar and line chart are so common that you can create them with whatever tool that lets you do data viz. You simply supply the data and the tool does the visual heavy lifting for you. But the more that you start to deviate from these standard charts, the more that you have to supply other aspects of the visualization as well, such as where on the screen should my data be placed. And it can take a little bit of time to figure out and calculate these things, but it can get you some truly unique and effective results. For example, the Olympics piece is just actually a whole lot of rotated and stacked bar charts. It's a very structured concept, and they follow the same idea, but they also depend on each other. And initially, I tried to calculate all of the rotations of all of these feathers and circles in JavaScript. But after having written 30 or more lines and still not achieving something that I knew I could do in 2 lines in R, which is my favorite data viz, data prep and analysis tool, I just pulled these preparations into R as well, even if they were so-called visual variables. By which I mean that they have nothing to do with the data, but only with how it's laid out on the screen. So, for example, I pre-calculated the initial rotation that the circles would need to eventually have the center at the bottom. How far then each of the slices would have to be rotated to have, based on what came before. The only placement variable that I kept calculating in JavaScript was the year scale from the center outward, because then I could easily shrink or expand the circles based on screen size. But even each metal's offset from the center is something that I calculated beforehand. So it's perfectly fine to pre-calculate these visual variables and attach them to your dataset. And that can be useful for fixed datasets more often than you think. It can either be way easier to calculate these things in another tool than the one you're going to use to visualize your data with. And for those visualizations that end up living in the browser, it could save you a lot of browser calculations, especially with things that work on simulations, making it faster to load, again, especially on mobile. And a personal benefit for me is that it makes my JavaScript files a lot more readable. And Shirley and me have also filled many pages of our notebooks with sketches because it helps us think and lay out ideas beforehand. And my sketches are often very simple, only focusing on the main abstract shape that I want to fit my data into. Colors and lines and details, these are things I only vaguely think about, but don't act on until I have the data on my screen. It's just that there's no use to really spend any time on these things until I figured out that the data actually works once I've morphed it into the main shape. For example, for the Olympics piece, I was actually inspired when I saw a peacock feather with the emphasis having more on the later editions. But I had no idea if that would look all right once I finally placed all 5,000 metals together. So I had to see if the general shape would work before moving on. Well, it took a few steps, and because the colors here were so obvious, I already used them. But typically, I start with rainbow or black and white. But it took a few steps, and eventually I saw that, yeah, it did show potential with the actual data. But for networks, it's actually quite hard to draw anything less abstract than just circles connected by a line. And that's because the best shape, the most effective one, is so inherent to the actual connections within your data. And for October, I dove into royalty. I've always been intrigued by how intermarriage the royals really are. Are their cousins twice removed, or 6 times removed, or what is it? And thankfully, I found this gigantic genealogy data set that, of the European royal houses. It was from 1992, so I had to spend a lovely evening on Wikipedia adding 1 or 2 more generations in the main line of succession. But yeah, I learned a lot of things too. And here we have the end result, where the current royal leaders are the bigger circles, and then everybody is connected to their parents, their partner, and their children. And if you hover over a person, you see how far 6 degrees of separation reaches into the web. So for example, this woman, Pauline of Württemberg, is connected to 6 of the current royal leaders through only 6 hops. We can also focus, for example, on the Queen of England and maybe Sissy. And then we see the shortest path between these two. So we can see that these are quite unrelated, but if we go to the King of Norway, you only need to go back 3 generations before they split up. So they're like achter neef. But anyway, but when I first started out with this data set, I had no idea what it contained. So I just put the information on the screen using the most basic network settings, and then this happened. An explosion of points and lines moving out of my screen, just like that. It kept going. So I thought, well, okay, I'll rein in that gravity a little bit, because that's how these simulations work, with like a gravity and repulsion idea. But then I was immediately stuck with a useless hairball. So I thought, well, I can maybe color the points by year of birth, but that didn't help at all. Thankfully, in a browser, you can tweak physics, and I can have gravity depend on a variable. So I pulled the web apart by year of birth as well. And this was better, but it was still a rather uninsightful bundle. And at this point, I'd already invested several hours into trying, playing with the network settings, trying different kinds of connections, adjusting my data. And I was really ready to just give up and try a different angle, like how much are the royals spending these days. But I gave it one last try. And that's when I decided to focus on the current royal leaders. So I placed these in a line, and then I let the vertical gravity depend on which of these royal leaders you were most closely related to. And that's when I finally saw it, insights. For example, that this network here with the Queen of England and Norway and Denmark is actually very interconnected. But that here, the Prince of Monaco line separated from the rest 200 years ago. And it was only at this point that I started worrying more about the other design aspects of the visualization. And networks often remind me of constellations, and I have a really big astronomy bias. So that's really the only reason I made it look like a starry night. And the thing, though, is that I could have never designed this visualization beforehand in Illustrator. I had to go hand in hand with the actual data and apply my design choices to all of the data simultaneously to see if the results were both interesting and engaging. But getting back to actual sketching. During September, our topic was travel. And I took the opportunity to visualize all of the vacations I've ever been on. So with the help of my parents and sorting through all of my analog childhood photos and my travel journals, I created sort of a list of all the vacations and metadata about them. And I wanted to keep this month very minimalistic. So just a row for every year that I've been alive, and then colored blocks on the periods where I was on vacation. And then the blocks would be sort of decorated to give an idea of where did I go to, what type of vacation was it, how much did I enjoy it, who I was with, and so on. So I drew the sketch around that idea. But when I looked at it more closely, I realized that my mind had glossed over something rather important. Namely, that I'm only on vacation for a max of 4 to 5 weeks a year, which isn't bad in general, but it's not even 10% of a year. So in this sketch, sadly, it seems like I'm on vacation for like a quarter of a year or maybe even half of a year. So if I would create this with the actual data, it would be mostly empty, which wasn't what I had in mind. So I tried to find different things, sketching new ideas, and I decided to try something rather unusual. I would squish any month in which I hadn't been on vacation. That would make it pretty darn difficult to compare months across the years, but that wasn't my main point anyway. I instead wanted to visualize trends in my vacations, from mostly sun-driven and early childhood to culture in my teens and nature these days. And by sketching out the designs first, it made me realize that my initial idea wasn't going to work and guided me towards sort of a new approach. And here is sort of the final result of 30 years of my vacations. Although I have to admit that my favorite part of this month was really just reminiscing with my parents over the photos and things we remembered or differently remembered of those vacations. And another example, after seeing that peacock feather and being inspired for the Olympics piece, I started drawing some feather shapes. But initially, I thought all of them would be completely filled with the same color in a row. And then while drawing, I was like, wait a minute, not everything is like hockey and soccer and these things. Some things have like many, many medals, so how would that work? And I have some other question marks here and there and ideas and things that I suddenly thought, wait, that's not going to work. I need to do something about that. So the next day, I tried to explain it to a friend. And again, while drawing up parts of it, I noticed that I was making thinking errors, that this wasn't going to work. So only by iterating and trying a different shape, fixing my thinking errors and trying again, did I get to a shape that sort of seemed to work. So instead of going straight from an idea in your head or data into the computer, sketch out your idea first. It's the quickest way to quickly catch thinking errors, and you don't have to be an artist to make data viz designs. They're mostly rectangles, circles, and simple curves anyway. The thing is this, that if you cannot make it work logically on paper, it is definitely not going to work on the computer with the actual data. And another thing I try to investigate while sketching is how to add extra context. So how to provide more information about the main insights that I want to convey. And for example, even though the Olympics piece was already pretty dense in data, I couldn't resist adding information about the Olympic and world records, because every athlete there tries to break at least the first, if not the latter. So for each of those records, I added a small white dot on a medal if it resulted in a record, such as here for Usain Bolt's 200-meter dash in Beijing. And a way for me to think about adding these extra details is to think about the visual channels that I still have available after I have the main chart standing. Let me explain that a bit more with another example. So typically, during exactly 1 week in the year, I believe more than half of the Netherlands listens to the same radio station. I think some of you may know what I'm talking about, but it happens during the last week of the year when the 2000 best songs ever are aired, counting down to the new year. I'm a big fan, so I asked Shirley if the topic for December could be music, so I could tackle these 2000 songs. And my goal was to visualize what decade is most popular in terms of song release year. And the base visual became this, where each song is a circle, and they're clustered to sit at the year of release, from the 60s until today. And then the size of each circle is the position in the top 2000. The color represents the highest position it ever reached in the weekly top 40s. And we can see that the 70s and 80s are the most popular decades still, and that we're sort of trying to forget the early zeros, but that we're getting back in good territory again. And, it was just, the thing is, I felt like this was just a little bit too boring still, and there was so much more interesting information in the data, like the band names, the song names, rankings. So I wanted to try and add on to this. And so I thought about, well, what visual channels do I still have free? Well, I could add a stroke, or I could add some mark on top, or even do something with textual annotations. So that's sort of what you see here in this very blurry kind of sketch, some of those ideas. And then in 2016, sadly, Prince and David Bowie died, so I at least wanted to highlight all of their songs and show how this had changed with respect to the list of the previous year. But I also could use the rankings of the song in different ways. So I could annotate all of the songs from the most popular band, which is still the Beatles. Or where is the highest riser of that new year, or highest riser overall, newcomer, or to single out that Pokemon song, or even just to highlight the top 10 songs more clearly by adding an extra mark on top. And I felt that by adding these extra details, the visualization could be more fully understood, enjoyed, and it just made for a visually more interesting piece as well. So even though it's key to get your main chart standing, after you have that working, try and add extra context by using remaining visual channels to add new variables that can supply context and give the truly interested reader even more ways to dive into and understand the information. So as expected, most of my hours are spent into actually putting the data on the screen. And here are some of my perhaps less obvious coding lessons. So for the very first month, the topic was movies. And it was pretty obvious to me that I wanted to do something about The Lord of the Rings, which is my favorite trilogy. And I thought that with the popularity of the movies, that there would be loads of information available online. But that didn't turn out to be true at all, until I came across a real gem of a dataset. So somebody had created a list and counted the number of words that each character spoke in each scene of all 3 extended editions of The Lord of the Rings. And how amazing is that? Somebody did all that work. I knew this was one of those cases where the data let me. So I looked at this data set and was like, what do I want to know about when I see this? And for me it was, well, how many words has each member of the fellowship spoken at the different locations? However, as you may be able to read from the screenshot on the left, there's no location information in it. So, together with the scripts found online and my own memory of having seen the movies way too often, I just manually added location information to all 800 rows of the fellowship data. At the start, I even split up scenes because they switched locations, and then I would count, like 10 were in this one, and then 12 were in that one. That was so not used to, I mean, wasn't necessary. Well, I made some designs, and I came up with this one where the members of the fellowship would be in the center. The locations spread around in a circle, and then they would be connected by these strings, where the width of a string would represent the number of words spoken by that character at that location. However, this chart form didn't exist. I mean, there was no tool that could easily do it for me. However, it did remind me of a chart that did exist, which is called a chord diagram. So I thought, well, maybe I can see if I can transform the chord diagram into my sketch. Here we have a basic stripped of all text chord diagram. And the most fundamental aspect to me was to see if I could somehow move all of these outer strings towards the center, which turned out to be easier than I expected, which is pretty rare for me in coding. But I was happy, and then well, getting rid of that space that was no longer needed, putting in the actual Lord of the Rings data, maybe some better colors. And we have 9 members of the fellowship, so yeah, we need to make sure that they end up at the right vertical location. But now I was seeing that, wait a minute, my design didn't take into account that it could get quite busy in there. So simple thing I could do here, because it was a nice 50-50 split, is pull the two halves apart. However, now I noticed that these strings here, they were looking a little bit odd, especially in the top and bottom. So I finally took it upon myself to learn how to write my own SVG paths. Because I make all of these visualizations using D3, which is a JavaScript library that has become, I guess, the standard in online data visualization. Even if you think you're using something else, that thing probably uses D3 under the hood. And D3 often does things with SVGs, or Canvas, but this typically the default would be SVGs. So all of these things are SVGs, and D3 helps you create them, so you don't have to write the paths yourself. But now it was finally time that I learned how to make my own ones based on data, which was the thing that took longest in this entire project. But that's kind of how I ended up with this new chart that mutated from D3's chord diagram. And because we have so many of these chords visible, this one could really use some interactivity to provide focus. So I can hover over a location and see all of the members that spoke there, or vice versa, hover over the person and then see how many words he spoke at those locations. And I have this sort of a piece of text below that I give insights about a small thing that I understood from the dataset about this character. And I always have to share my favorite one. So Boromir, who is really only alive during 1 movie, he still manages to speak more words than Legolas does in 3 movies. Yes. I never knew that before. And I don't even want to say how long it took me to get these Elvish translations. I still don't know if they're correct, but I guess it's the small things. So many people have done amazing things, and they share this or a way to recreate that online. So even if you think you are creating something new, that doesn't always mean you have to start from scratch. Pick the thing that most closely resembles your design and see if you can adjust that. Remix what's out there already. And there's actually nothing that I learned more about during this collaboration with Shirley than learning how to make my own SVG paths and how that can be connected to so many more possibilities in terms of design and creativity. From simple curves instead of straight lines in my visualization about royalties, to sweeping arcs in my visualization about fantasy books, to the feather shapes that I really did create for the Olympic Feathers project but never made it to the final result. The Olympics, Lord of the Rings that started it all, and more recently these radially flowing lines between 2 circles, groups, things, I don't even know what to call them. But another project that is heavily based around custom SVG paths has to do with the Nostalgia Month. So I went back into something that I was crazy about during my teens, Dragon Ball Z. And for those that sadly don't know it, Dragon Ball Z is an anime that revolves around fighting. So I thought it would be fitting to visualize all of the fights that occurred during this anime. And then, again, supplying that context, showing things about special things that happened during the fights, like special states, Super Saiyan versus final, almost final form thingies, or Super Saiyan 2, these things, or many against many. And the base of the visualization is really just this. So each fight is a cluster of circles where each circle represents the characters that fight each other. And then to more easily follow these characters from fight to fight, I wanted to connect their fights by a line. And I started out with a collection of so-called quadratic Bezier curves, which give you the option to pull on these line sections by moving these hidden anchor points. And to make it more interesting, I decided to pull harder if the distance between two fights was farther apart. And then somebody gave me an idea that I could use the side of a fight to denote good guys versus bad guys, which can then show you that for this character, Vegeta, he started out as the main bad guy before moving around and, finally mostly becoming one of the good guys. And then introducing the other characters, and actually I learned things about Dragon Ball Z that I never realized. If you want to know, you're a fan, come ask me afterwards. I can talk about this. But I just wasn't liking the single thickness lines. They were not conveying the dynamic nature of the fights. So instead, I wanted to create a shape that I could fill with a color, which would mimic a line of varying thickness. So as usual, I would go to my notepad and draw out my desired end state in either math, and here it would be SVG coordinates, which came down to really just flipping the path back up again, using different amounts of swoosh. And implement this, I've never been able to find a better word for that, swoosh. But after implementing that small change, I felt that the lines connecting these fighters was just a lot more visually interesting and more fun to play with. So even though I've been talking about SVG paths right now because they are so inherent to what I'm doing, in general, the lesson for me became that you should really try and thoroughly understand the advanced functionalities of your tools if you want to go beyond the standard examples. So I was using D3 for 2 or 3 years before I finally took the time to learn how D3 really makes these SVGs for me. And it opened up such a world for me in terms of these possibilities that I could shape my data with visually. So I wish I'd done that sooner. Something else I have a lot of fun with, typically, always, is math. And here is my addition to our collaboration month with Google News Lab. And being a non-native English speaker, I was interested to know what of the languages one have translated into English using Google Translate. From the most translated word for each of the chosen languages. For Dutch, for example, that is weirdly enough collega. I think it's because you don't really know where to put all the extra vowels. But typically for the other languages, it's things like good or beautiful. To the top 10 for each of these languages to finally the similarities between the languages. And for this top visualization, I really wanted to string together these most translated words by a swirling arc that would represent the 100 most translated words overall. Something that would look very organic, like this. But for the life of me, I couldn't figure out something that would be similarly organic and in a mathematic kind of way, and still be responsive and update to different screen sizes. So eventually I went with this idea of beads on a string slowly zigzagging down. Of course, I typically, or always, make mistakes in my math, which reveal themselves once you finally code it out, but then you start iterating until you get it right. And eventually then I could use the screen size to then see if it should either be 4 or 3 or 2 beats wide on mobile. Another one that was an interesting math and logic puzzle to solve was the last one, in which if 2 languages have a word in common in their top 10, it would be connected by a line. But initially, I wanted to actually make these visualizations completely out of the words that they represented. So I wanted to replace these lines by the words. And I should have known that would be a complete mess. So I had to compromise and only put these words on the lines connected towards the central chosen language. But then it became really important that these words were placed in the most upright manner possible for readability. But that gave quite some convoluted calculations in terms of these text paths on which the lines are drawn, the words are drawn, which became very obvious once you click one of these outer languages to move it towards the center. Not quite what you expect to happen, I would say. So here is again where math and logic came to the rescue, It took a few more pages from my notebook to figure out the final result, but eventually I came up with an idea that seemed to help. I also have a really small notebook, so it takes a lot of pages. And now it's the way that I think a user might expect it to work. And what I'm doing is really more of a hack. So when you click one of these circles, I fade out the words, and then I immediately replace all of these lines by their final states, but reverse engineer to look like the initial ones and then transitioning them to the final ones. Yeah, text paths are fun. So the lesson here is very simple. Learn to love math if you don't already, and especially geometry. If you don't, it's typically your best friend in finding solutions to problems with visual stuff. Never mind that sentence. So I want to end with one of my favorite lessons. For February, our topic was nature. And I'd always wanted to do something a little bit more towards data or generative art. And the apparent randomness of nature felt like a very good fit to that. And it also reminded me of butterflies, how their paths always kind of feel random to me. So I wanted to mimic these butterfly-like paths across the screen using data by butterflies to drive the characteristics. So the main species color would signify kind of the color on the screen. The species itself would define the type of line. And finally, the size of the butterfly would represent sort of the thickness of the lines. And then using lots of semi-random number generators and inspiration by the likes of Jared Tarble and Convergent, did I let my butterflies free across the screen. And this is the only month in which I make no attempt to make the data insightful. It is really just something that I wanted to create that was based on data that, I guess, mesmerizes the audience, to keep them looking as the screen fills up with more and more butterfly paths. And I guess creating a sense of delight for your audience is an important way to keep them engaged. And this is a very good way to get your audience through the more complex visualizations. And they can be done in quite subtle and diverse ways. For example, on a flight back to Amsterdam, I was without Wi-Fi, so I couldn't really do anything crucial. So I thought, well, maybe I can just make an animated legend of my visualization about fantasy books. And other non-essential things that I've done are, the animated GIFs that have the most memorable moments of Dragon Ball Z. Having hovers for my music visualization so people can see exactly what song every circle is, or even turning the top 10 songs into tiny vinyls. Or having annotations about weird and silly events that occurred during the Olympics, such as Henry Pierce having to stop for ducks during the rowing event, but still managing to win gold in the end. So even though getting the data on your screen in such a way as to make it insightful is key, it's the other things to add, like annotations, animations, weird legends, GIFs, and more, that can make it truly unique and special and even more of a delight to investigate. So take the time to think about these things as well. And I guess one of the best things about doing a collaboration is the fact that you're not in it alone. So even though Shirley and me were creating our visualizations separately, we were often sharing our results throughout the project. From discussing initial ideas, to sharing in the joy of finding an appropriate data set, to sending loads of screenshots of work in progress to ask for feedback. And we started out as two people who sort of knew each other and had a good time during the conference, and by the end of the year, we developed an amazing friendship, and we talk to each other practically every day now, and we even work together professionally on our bigger client projects. So I guess we are each other's biggest clients. I hire her, she hires me. So that's fun. And in that sense, I guess, if you are thinking of embarking on an ambitious project, I can definitely advise you to search for a partner. I think it also helps you going more easily. I was always motivated to work another evening on my own project when I finally when I saw screenshots of Shirley's progress. But I also didn't want to let Shirley down, so I was way more motivated to stay on track. But it will definitely help if at least one of you is responsible, so you don't both slack off, that it's someone that you respect, and that it's someone that you trust or you think you can learn to trust, because that is crucial in giving and receiving feedback. And also, it's good to realize that even though, no matter how enthusiastic you might be right now or how much fun you're already having, at some point it will get hard and it will require a level of dedication. But try again if you're having a bad day, because with each new app or demo or visualization that you create, you will learn new skills. And those skills you will grow again on the new projects that you create. So at least that's for me the way that I got from nothing to doing this in my free time to now having a career out of it. So I think these personal projects are an amazingly worth your time, and definitely do them. So although I've been taking you along on a journey through my projects and lessons, Shirley also created a visualization each month around her own spin on the topic. And here is a sneak peek of two of my favorites. So the first one is called Film Flowers, which is her take on our movie month, in which she took the top summer blockbuster movies for every year that she's been alive and turned them into flowers. So each aspect of the flower represents data. So the petals is the age ratings, the colors is the genres, the number of petals is the number of votes, and finally the size is sort of the average IMDb vote. And that way, each movie is turned into its own unique flower. And I really like this project because of the artful way that the end result looks. You can paint it out, hang it on a wall, but still keep comparing movies across the years. Now, this one is Shirley's favorite, Batman and Robin. And the second one is about Hamilton. So although published during our Books Month in November, she had been working on this project for 3 months prior to that. That's how crazy she is about Hamilton. I can definitely advise you to read her write-up of this month alone to see her dedication in the data gathering. But yeah, this visualization takes you through all of the lines that were spoken in this musical. You can see who sang together, and if you go further down the page, she explains the story arc of one character in particular. And I really love just the general sense of delight that you get when you scroll through and interact with the different elements on this page. So yeah, I can definitely advise you to look at her other months as well, because they are each fun and unique and gorgeous takes on our topics. So during this collaboration, I've learned that you can find data in the weirdest of places, that sketching helps weed out thinking errors, but that you can also sketch with code. That, I guess, SVG pads are amazing, and math is too, but I already know that, of course, and that, surprisingly small things can add a sense of delight to your audience. And we didn't set out to learn or be confronted by these things, we just wanted to have fun, and in that we definitely succeeded. But even though the year's already come and gone, almost twice, we are still not quite ready. I am currently working on my final month. Shirley is somewhere in between for her last 3 months. And that's because we were having fun, but especially when we both started freelancing, it was just too much to do this on the side. So we decided thinking a little bit more slowly. So if you want to, you can still follow us in our final months of data munging and sketching and coding up our ideas into often fun and weird and overtly elaborate visualizations. Thank you very much for your attention.
So, who isn't in awe? I think you can make a visualization of the word jaw-dropping on Twitter during your talk.
Cool.
I think people were very impressed.
Yeah, I've been telling people how I have the pro of having a very visual output of what I do.
Yeah.
So that's always a benefit.
One of the comments was not a question, but when I grow up, I want to visualize data sets like Nadieh. It's from Anke. I thought that wrapped it up quite well.
That's really cool.
And a question which I think is raised by a lot of people: where do you find the time? Are your days magically longer? From Sebastian.
Okay, so there were a few reasons. One is I don't have kids. I have a cat and a boyfriend. The other one is I am not the kind of type that likes to go out and to bars. So, evenings and weekends are when I do this, I guess. I don't have, like I said, I don't have free time left. I'm behind on many shows. I haven't watched Daredevil season 2. I wanted to do that for a year.
So your advice is stop drinking, stop Netflix, and you can do this too.
Yes.
That's a good advice for a lot of things, I think, in life. You did a lot for fun, I think. Not certainly for, but you were also talking about client work. Can you tell a little bit more about it? How you apply this for in your daily work?
Yes. So on the one hand, something that we didn't set out, because when we started this project, I at least wasn't actually thinking about freelancing. I guess we wanted to create, but it's been an amazing marketing system in a way, because on the one hand, I can show what I can do, on the other hand, I can also give a sense of style. And also, what I also alluded to in my talk is I learn techniques here, because here I can experiment and grow crazy that I can then apply in my client works. But the things that I do for clients typically are either brand or promotional based. So they want to create something that's based on their data. They have some insight, or they just want to show, look, we have tons of information, and you can find good insights from there. But they also want it to be visualized in some way that grabs the attention. So so then they ask me to help out with that. Or there are clients where they have a complex data set. They figured out themselves that line charts and bar charts isn't cutting it. And they ask me to make a very custom-made, specifically for their data set prototype that their developers will then take and get into the client system, which typically they need someone, a database specialist, to come up with the idea of how to put the data on the screen.
Yeah, because you already have this big market for like infographics, which mainly some are images, and this seems to be like much richer, much more detailed. So probably journalism is most obvious probably to use this kind of.
Yes, there are many. New York Times is amazing in what they do with data visualization, but also National Geographic. I've worked for Scientific American, which is fun because you can assume a little bit more graphical literacy. But it's also it can be as broad as aviation to retail to oil to so many companies these days have data in large amounts. And I see infographics to me is usually separate statistics that are typically big number graphic. But data visualization to me is where the data itself creates this visual thing that you see.
Right. Yeah. And if you were working very closely with Shirley, you talked a lot about. And does she work the same as you, or do you also have different tactics in finding data sets and visualizing?
So my background is from astronomy, so I have more on the data analysis side. And Shirley comes from computer science, so she's very strong on the coding side, whereas for me that's more self-taught. So we like a Venn diagram where I can do more of the data analysis preparation, and I do that in R, and then I make the visualization with not nice looking JavaScript. And she uses Node to prepare her data, but maybe for the harder algorithms, maybe she is not able to do them because you would need to have a more like a Python or R to figure that out. But together we're a great team from start to finish.
Yeah, so and you work with techniques like D3.js, I heard a lot, SVG, that are the main techniques you're working with also? Yes,
D3 is sort of the tool that helps you under the hood, but on the visual side, it's usually SVG for small data sets, Canvas for something bigger, WebGL if you want to go really crazy.
Cool. Thank you so much for this presentation. Another applause.